Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Senyola Olu and I've been guiding you through the chemistry course. In this particular lesson, we'll be considering the chemistry of the Earth and space. We'll look at our first subtopic, which is Earth. Then we'll look at the using of spectroscopy to study the planets and the star. We'll also consider the solar system, then consider stars, and we'll talk about the space travels. Alright, let's begin. The Earth. The Earth is our planet in which we live. It is the third planet from the Sun, the third planet in the solar system, counting from the Sun. It is a planet which is abundant in oxygen, nitrogen, and a lot of other minerals. A lot of minerals, a lot of materials have been discovered on the planet. The planet itself is self-sustaining, and it has been living, according to scientists, has aged about it's about 4.5 to 5 billion years old, and it is still aging. We're still here on the planet. So let's talk about the planet itself. The planet is made up of several parts. We can split it into about 4 parts, but for the purpose of this lesson, we'll talk about 3 parts. And those 3 parts are the hydrosphere, the lithosphere, and the atmosphere. The 4th part is what we'll call the biosphere. Alright, let's begin with the lithosphere. The lithosphere talks about the part of the Earth that is occupied or that contains solid material, that is rocks, landform. That is what we call the lithosphere. The lithosphere occupies a large, vast part of the Earth, and it occupies a very big part of the Earth, especially where where humans and plants, where life is found. Of course, we also have the hydrosphere. The hydrosphere refers to the part of the Earth that is occupied by water. Part of the Earth that is occupied by water. Of course, the hydrosphere is, according to scientists, the hydrosphere is relatively larger than the lithosphere. And we have the largest part of the Earth, which is the atmosphere. The atmosphere. The atmosphere is a part occupied by gases. The atmosphere is the part occupied by gases. Well, the atmosphere is occupied by air, which is the gas which flows in our system. The air contains nitrogen, oxygen, carbon dioxide, and many other gases. We have nitrogen about 78%, oxygen about 21%, and other carbon dioxide about 0.03%. Rare gases about 1%, 0.1%, and other substances like dust and water vapor occupy the rest of the percentage of the atmosphere. Now, our atmosphere, I said that there's supposed to be 4 parts earlier, yes, and the 4th part I mentioned ought to have been the biosphere. The biosphere refers to the part of the Earth or a part of a location where there is life, where life can be maintained. So far, so good. The Earth is the only is the only planet in our solar system that sustains life, and our Earth has a satellite which is known as the Moon. Alright, we have talked about the Earth. Let's quickly look at spectrometry, using spectrometry to study the planets and the Sun. When we talk about spectrometry, we're talking about spectra. Of course, when we're talking about spectra, we're talking about light. We're talking about emission, radiations. So we have 2 types of spectrometry. We have the emissive spectrometry, that's the spectrometry of emission, and we also have the absorptive spectrometry, that is the spectrometry of absorption. So some bodies do emit light while others absorb light. Some reflect it, some absorb it, some create it and give it out. So we use the knowledge of absorption and emission to do the estimation of what condition a particular location is at. We use the knowledge of emission and absorption to do the estimation of what the particular body or location is at. So when we use this light, we know how much of energy is found in the sun, how bright the sun is, and we calculate the distance of the planets from the sun. We can also tell. Yes, consider emissive or emission spectra. These are spectra that give out light. These are spectra where light are being given out. It is usually recognized, identified with white spots. And when we talk about the absorption emissions, we're talking about the regions where light is absorbed, and we usually identify this part with dark spots. So when we look at the dark spots and we look at the light spots, we see the spectra, and we're able to tell the distances. On your screen about now, you should be seeing a particular spectra showing the distances and the of a particular sodium, different types of spectra. So we see each of the different spectra that we have there. Now we use all these experiences to estimate the temperatures, the operations and conditions of each of these planets. So let's discuss the solar system. Our solar system, when we say a system, it means it contains certain planets and a major star. Some systems actually contain more than a star. I've heard of a particular system that has 2 stars. Well, I wonder how life can be sustained in such a location, but thank God it's not a problem to deal with that. So in our solar system, we have our star, and our star is recognized as the sun. The sun is in the center of our solar system, and all the other planets revolve around the sun. All the other planets revolve around the sun. The sun is stationary. The sun does not move. So as against what you think you are seeing when you are on the earth, that you're seeing sunrise and sunset, the sun doesn't rise, the sun doesn't set. It's the earth that is moving. You will learn more about that in geography. Alright, let's concentrate more on what we can talk about here. The sun has a surface temperature of about 6,000 degrees Celsius. It emits light. It is the only body in the whole of our solar system that actually emits light. All other bodies reflect light. The moon does not produce any light. It's the sun. In the core of the sun, it contains a mixture of gases. The sun is made up of a mixture of gases, varying from hydrogen to some hydrocarbons, and even some. It's a blowing nuclear reaction, and actually, our sun is about 10 billion years old. It's about 10 billion years old, and it is expected that in the next 10 billion years, our sun will die. In the next 10 billion years, our sun will die. Thank God I won't be alive to see it die that particular time. About now, a particular diagram will be on your screen to show the arrangement of the sun and the other planets in the orbit. Of course, the sun is about 10 times the diameter of the earth and about 333,400 times the mass of the earth. So it pulls the earth with a gravitational pull about 28 times stronger than that of the earth. So if you actually pass the earth and you cross towards the sun, the pull with which the sun would attract you towards itself is about 28 times the gravitational pull that we are currently experiencing on the earth. So the sun is a gigantic star. Of course, it is a star, and every star is supposed to be larger than all the planets in its system. Every star is expected to be larger than all the planets in its system. Let's consider the next one we have here, which is the next body to the closest body to us. The closest body to us is the Earth's natural satellite. The Earth's natural satellite. When we say satellite, what do we mean? Anybody that floats about or revolves about a particular body in space is described as a satellite. It will move about a specific part. And that's what the moon has been doing to the earth for years. I don't know how long, but for like forever. The moon has been moving around the earth and like that. So it is the earth's natural satellite. The moon does not produce light. When you see the moon out in the night, what you are seeing is the reflection of the sun on the moon. The moon actually is reflective. It reflects the sun's rays to us at night. And we see it and it looks like we are looking at the moon shining its light. A picture of the moon is being displayed on the screen about now. And the moon the moon revolves around the earth about 27.32 times 27.32 days. That's how long it takes to complete its axis around the moon. And of course, it is very, very cold when it is not in the sun, and very, very hot when it is out in the sun. When it is out in the sun, the moon is about 140 degrees Celsius, and when it is at the back, is about minus 180 degrees Celsius. So the moon is always at extreme temperatures. Okay, other things about the moon. The moon is actually about 4.8 billion years old. Yeah, you see, the moon is actually about 4.8 billion years old. So let's take a look at one of the planets one after the other, starting with the one closest to the sun. We'll be having their pictures being displayed as I talk. All right, now we have the first one, which is Mercury. The planets are terrestrial bodies. Of course, there are terrestrial bodies in space which have size and density. And the first of them we have here is Mercury. Is the smallest. It's a small planet. No, not the smallest. It's a small planet. It is rocky and it is sun-scorched. It has no moon. The surface area of Mercury is just like that of our moon. It has no. The temperature of it is so high it can melt lead. And at the back of it, that is the place where the sun is not touching, is so cold that nothing can survive. So it experiences extreme heat and extreme cold. Its atmosphere is scanty and is composed mainly of hydrogen, helium, and neon. It is about 1 over 16 the volume and mass of Earth. It's about 1 over 16 the volume and mass of Earth, but it has nearly the same density as Earth. This suggests that it most likely contains some important heavy dense metals in its core. Venus is about the same size as Earth, same size, mass, and density as Earth, about the same thing, and it's covered completely with white opaque clouds. Venus contains 96% carbon dioxide, 3.5% nitrogen, and traces of other gases like sulfur dioxide, argon, carbon dioxide, oxygen, and the atmospheric pressure is about 60 to 100 times that of Earth. Surface temperature is about 460 degrees. No life can survive. Of course, we know our Earth. The Earth is not spherical as we thought it would be. It's almost spherical. Vertically, that's the polar radius is 6,356. Horizontally, it is 6,378, and that is where we live in. It supports life. Mars, on the other hand, is a dry, cold planet. Temperature ranges between 25 degrees Celsius in the afternoon and minus 40 degrees Celsius at night. Mars contains majorly carbon dioxide, about 96.5%, nitrogen about 1.5%, 1.5% of argon, traces of oxygen, carbon dioxide, and water. Jupiter is the largest planet of all the 9. It has a diameter 11 times that of Earth, a mass 318 times that of Earth, and it has a very, very big gravitational pull. the temperature of density surface temperature of Jupiter is about minus 140 degrees, but it has a core temperature estimated to be about 30,000 degrees Celsius. Jupiter has 16 moons, and the largest one, and of course, Io is one of its large moons, and it has 8 active volcanoes on it. 8 volcanoes on the moon of Jupiter. Saturn is the second largest planet in our solar system, temperature about minus 182. Saturn is circled by a series of rings, and it is decorated with those rings. It has about 20 moons. We are still counting the moons of Saturn. Uranus is a very, very cold planet, receives only about 1 over 350 light as much as Earth. It is unusual in its rotation, so it rotates in sideways direction until it is almost horizontal. So its surface temperature is about minus 185, and it has 15 moons and counting. Neptune, also, of course, about the same size as Uranus, thick stormy atmosphere of hydrogen, helium, white clouds of frozen methane. Neptune is very, very cold planet with about a surface temperature of about minus 205 degrees Celsius. It has a moon. It has one of the moon that is volcanic, and the temperature of the moon is about minus 240 degrees Celsius, which is the coldest temperature of any body recorded in the solar system. Pluto is noted to have surface temperature of about minus 22 degrees Celsius, and that's when it is facing the sun side, and when you look at the back side of it, it is about minus 503 degrees Celsius. All substances on Pluto must be in their gaseous in their solid state. Everything must have frozen, and that makes us talking about asteroids, comets, and meteoroids. So when we talk about asteroids are rock particles floating in space. They are rock particles floating in space. The same thing about comets, only that in comets, asteroids move in specific paths. They move in specific paths, and they are plenty. They move about the orbits of about the particular orbit of theirs, and you find very many asteroids just after mass, and that is what we call the asteroid belt. So find very many asteroids loitering around there. It's more or less like a parking space for asteroids, and they move in troops, pulled by the gravitational force of the sun, and they are forced to move around us like that. Yes, when it comes to comets are a body of gas, usually escaped from other planets, or what used to exist probably from the sun, and it is moving with a very fast speed. Because of the fast speed with which it is moving, it has a tail. But before it can strike on a particular surface, you see it would simply totally dissociate before it enters into a particular location, since it is ice molecules and sometimes just frozen gases. By the time they get to a certain closer to the sun, they fall towards the sun, they fly towards the sun, and when they get closer to the sun, they simply burn off, since they are gas particles. Also, we have meteoroids. Meteoroids are rocks, smaller rocks that come from either used to be planets or used to be solar systems, and they find their ways, and sometimes they crash into planets, and even occasionally we've experienced some on the Earth. Whenever they crash into planets, they come in smaller particles, which might make great craters. We have very many scars of great craters created by meteoroids hitting the moon. Our moon has protected us a lot from meteoroids, and when they fall in, the smaller particles are called the meteoroids. And in those metalloids, we find different metals from outer space. Okay, that's that about our solar system. Alright, let's talk about stars. Stars are self-illuminating objects. They're self-illuminating bodies. I told you earlier that the sun is our star in our solar system. So there's a particular chart that I want to show you. In this chart, they show how the stars are being graded. Of course, it should be on the screen right now. We have the giant stars, the supergiant stars, the blue giant stars, the white dwarf stars. We have also the main sequence. If you look at the tree, we have the O, B, A, F, G, K, M. Those are how we do the classification of stars. And of course, from the chart, you can tell the temperature of the surface area of surface temperature of the star is being shown, and the size of the star. The size of the star, by how much the star is brighter than our sun, is also being indicated in the main sequence. So our star falls in the main sequence. It falls in the main sequence. Of course, all these stars are millions of light years away from us. What is the history of stars? Let's talk about stars briefly. Stars are simply created by, most stars are born in different ways, but basically the basic way of formation of stars is that dust particles and hydrogen and other compounds would mix together, and there will be a supernova effect, and then we see a star coming to play. You see a star coming to birth. When a star is born, it looks blue, very big, and as it dies, it reduces and then it fades away gradually. So that's how stars are being formed and how stars move. Of course, we measure the age of stars. We measure interstellar distances in light years. We'll measure interstellar distances in light years. 1 light year is about 9.24 times 10 raised to power 15 meters. 9.24 times 10 raised to power 15 meters. So that is 1 light year. All right. The time it takes the sun to reach us from the light from the sun to reach us from the sun, that is the light from the sun reaches us on the earth in just 8.5 minutes. So when one photon takes off from the sun, in 8.5 minutes, it gets to the earth. So that is that about stars. Let's quickly talk about space travel. So space travels have been embarked upon far back as in the 1957. Since 1957, we have been embarking on space travels. Started by Russian when they went on the expedition on Sputnik 1 and Sputnik 2. Sputnik 1 and Sputnik 2. Of course, Sputnik 1 moved in October 1957, while Sputnik 2 moved in November 1957. The exploration was to go out of the Earth, and when it was successful, that was Sputnik 2 was successfully launched, and the dog called Laika was in Sputnik 2. It was the first flight with a living organism on it, and the dog actually flew and went to space. So the dog was the first living organism to be flown to space. In April 1961, Yuri Gagarin became the first man who went to space, and he went on exploration to view the moon. He had a 108 minutes trip. He orbited the Earth for 108 minutes and then returned safely to the Earth. And ever since then, much better explorations have been done. The Apollo 11 in July 1969 landed on the moon with Neil Armstrong, Edwin Aldrin, and of course the other scientists. Of course, it re-entered the Earth's atmosphere, and after that time, many other scientists have been to the moon to do several different explorations. Today, not only do we fly light equipments to the moon or to the space. We also send probes to go and view. We send mega telescopes to view what are happening in other galaxies around us. Not only in our galaxy, not only in the Milky Way, but we have had opportunity of viewing things that are happening several galaxies away from us. And we've come to conclusion that all galaxies are alike in a way, in a manner. They're all composed of stars and planets. And that brings us to the end of this particular lesson. In this lesson, we looked at the Earth, the chemistry of the Earth and space. We looked at using spectroscopy to study the planets and stars. We also talked about the solar system. We looked at each of the planets and bodies in our solar system. We discussed stars, and we briefly spoke about space travels. Okay, since we come to the end of this lesson, some questions will be displayed on your screen. Please answer them. And if there is any part of it which you do not understand, you can go over the video one more time for clarification. Thank you.